is Jaime Lopez Carvajal. He's from Colombia, far away from the University of Tolima, and is going to present the analysis of the change of the cover type in the subcatchment area of Hato de la Virgen in Ibagué, Colombia. Please make sure that your presentation is shorter than the title of your presentation.
Bien, muy buenas tardes. Mi nombre es Jaime López Carvajal.
So I'm Jaime López Carvajal. I'm a teacher at the University of Tolima in Colombia, and I'm working in digital processing, tele detection or remote sensors. I would like to present a project working on the development of a micro catchment in the urban area of Ibagué. So that project has been developed with different institutions, and it is dealing with the analysis of change in the subcatchment area. This presentation is some presentation that's been done from the perspective of a user. And I would like to give you some insight, some overview perspective of this project. So we are going to start with the introduction, the different concept about the different cover type. We are going to limit the size, the dimension of the study, and then we will study the result and the conclusions. In the majority of the countries of the world, we see a growth of the urban areas. And obviously, it is producing a series of problems. They are increasing, they are growing, destroying natural areas. And it has an impact on the environment. And it is producing a change of the landscape that some citizens are not perceiving, but in the long run, the environment is changing and the green areas are being replaced by buildings. So with this study, we want to analyze the type of changes that are occurring in this subcatchment area and which project could be launched to win back those natural areas or to improve the environment in which those citizens are living. All these urban centers, because of their growth, are interconnected. That interconnection is producing a reduction of the natural areas, and we have a lack of continuity inside the green areas. So we don't have a clear knowledge of what's happening in that physical space. So we need to have a general and time and spatial knowledge of what's happening in that natural space. This is why we are working with air photographies, not with satellite images, but with air photographies. And thanks to the analysis of those images, we can see, well, the changes that have occurred in those natural areas being contaminated, invaded by urban infrastructure. And then we are able to design some solutions, some projects to restore those natural areas. It is a petition, a query that has been made by the administration. We wanted to study the situation of the subcatchment. We had those these areas are suffering from drug addiction, from pollution problems too. So this is why the cities have decided to study well, those physical spaces in order to solve all these problems. And this is why we have decided to design this project to handle those problems. We want to make sure that the growth, the infrastructural growth is still happening, but respecting much more the subcatchment area. We see the profile of the country here, the borders of Colombia, and we see the Tolima province, the department of Tolima, as we call it in Colombia, and we have the little black dot is the city of Ibagué. You have here the geo position of the city of Ibagué. This is the study area here with the, you see the different urban areas. In blue is the subcatchment that is the target of our object, covering 281 hectares and belonging to two different villages. It is being divided into two different administrative regions. The data that we are using, I told you that we are using air photographies from 1984. We have been using two photographies. We merged them using the gvSIG software. 23 per 23 centimeters is the standard format that we have been using. Here you see a cut of the area that we are studying. And in 2003, these are the 6 pictures with a better, higher resolution. And you see the limits of the subcatchment area. You see, it's quite a long and linear subcatchment from the east to the west. And the flow, the river is there in the middle. You see this dark line ending in another subcatchment area with another river. These photographs have been shared with us by the city of Ibagué, and we have checked them against the National Geographical Institute. And the methodology that we have used for the processing of the data is that we have used topographic table from the different geographical institute, and we have been able to check that information in order to do the classification of data. We have used the GOS system for the study of the coordinates. Then, once we have identified the references of the images, we have classified those pictures. We have been using gvSIG software, and when I was saying classify the image, it took more than 2 days processing data. So we have decided to use another software. It is the multi-spec software for the classification. We've been using the maximum likelihood system. The multi-spec software is doing a pattern for the different areas, like for woods or for buildings. Well, why gvSIG is not filtering they are not doing it very well. We didn't get very good result with gvSIG at the beginning because it was giving too much detail about the different areas and it was taking too much time. So here we have merged different photographies from 1984. They are being classified using the software, and we are merging those from 2003 too. Then we classified the images. We compared both sets of images thanks to gvSIG, and it's represented an obstacle for us because the computers that we have used were not running very well. So I went to the IT department of the university with the experts there. We run it on different computers. In some it was running correctly and in others it was not. I don't know why. I don't know if it's because of the operating system or the software version. I don't know, but it was a bit surprising. So at the end, we got the cover changes and we studied the changes. The main result that we have obtained are the following. We've seen that the infrastructure that remain, infrastructures and the woods that remain woody areas represented 41%. It means that those areas did not change, but 60% suffered a change. The infrastructure is very important. I'm taking into account buildings, sports fields, roads. I'm including all that in one single category. The agricultural areas have also changed. The grazing areas represented 10.88%. And finally, the woods representing 9% have not changed because they were protected. Those woods were located along the river, and we have also taken into account the parks that are included in the subcatchment area. Those parks are not parks that were located along the river. They were urban parks that were built in the subcatchment. We see that the infrastructure represents 22% of the area that suffered a modification, a change. For example, because we have built a new building. Some buildings have been destroyed and have been transformed into parks too. This is why we have some changes here. Then in the grazing areas, we've seen that 21% of those areas have been transformed into built areas. And finally, 14% of the woods have been turned into, a built area or a grazing area. Here we see the classification. We have the map of the subcatchment area. In red, we see the built areas in 1984. We see two main areas, the green and yellow areas representing grazing and wood areas, and obviously they have almost disappeared with time. Here you see in 2004, we see how those areas have almost disappeared, and now they are built areas. You see the difference between the two slides. You see that they have been transformed into built areas with time. Here in this new map, we see the subcatchment areas that have not suffered any change, and they are, scattered across the subcatchment. You see one more time the built areas, the grazing and the wood areas. It's mainly wood and grazing areas that have suffered a change. Here we see the built areas. You see the woods too. Here we had no woods here in the riverbed, but now we see it. There is a new area. This was a grazing area, but with time it has been turned into a grazing area. So you see things are really changing in some areas of this subcatchment area. In this period of 19 years, we have seen a growth in the population that has decided to live in that subcatchment area. We have also seen lots of violence in Colombia. And this is why lots of people have been migrating away from the city center, people that have decided to live elsewhere, and they are settling illegally in those natural spaces. They are invading those river sides, and obviously, if it's we have heavy rainfall, well, we might have some flooding, and it might be very dangerous for the people that have decided to settle along the river. We have also seen the changes in the grazing and wood areas. They have reduced their cover by 15% for grazing area and 7% for woods. We have also seen a true destruction of the green zones. And thanks to that study, we have been able to restore the natural areas along the river. We have also been able to improve the quality of those natural areas. These were my contact details. Thank you very much for your attention.
Vale. Muchas gracias, Jaime.
Thank you so much, Jaime, for your presentation. And thank you for sticking to the time that had been given to you. We have a Q&A round. Are you guys hungry? Or are you very shy? Well, I do have a few questions. First, Claudio.
A 3D extension of gvSIG, or if you think it can be useful for modeling the groundwater and so on.
The gvSIG 3D extension?
Yes, you can...
Yeah, but it's difficult.
You can visualize...
Sí, pero es difícil. Es difícil. Porque el modelo numérico está basado en algo distinto. Hemos creado con algoritmos fishnet y hemos utilizado una librería Visa para visualizar el grid del modelo. Question for Jaime. First, my apologies if the gvSIG wasn't working well. We can talk to Nacho later. The software you used to perform the first classification of images, is it open source? It's called multi-spec. It's not open source, but it's free of charge. It allows for classification, but you need to choose only one pattern. And that's a drawback because you don't have the accuracy of gvSIG. But that's the way it is. The images were quite large. and it had 6 images times 5 megabytes, so maybe it was too big a file. On most computers it didn't work. In one computer it did work, but I don't really know why. Very well then, if there are no questions, let's break for lunch. Bon appetit. Oh, if I may jump in. If you want to join us for dinner, please register on your way out. Thank you.